All right. Well, we had this quiz, construct the graphs of four exponential reciprocal slopes, all of which we demonstrated last time. Okay? Nobody did it completely right, but some people were very close. Okay? But you got to know how to subdivide the rectangle. And then you got to know what the algorithm is, over one, down two, or whatever, over one, up one. You got to know where to start. Now, everybody did that real well in class. So everybody is fully capable of doing a good job of this. What I see is you didn't follow up on it. I told you there was going to be a quiz. I told you what was going to be on it. You didn't learn to do what you did in class, and most of you are not doing as well as you did in class when we did it. Okay? I'm not mad at you or anything. It's fairly common. However, you're going to need to change your habits if you're going to succeed in a math course. Okay? And the habit has to be, you know, there's going to be a quiz, do what's necessary to prepare for it. Because if you're not prepared for the quizzes, when it comes time for the test, you're not going to know how to prepare for the test. Okay? This isn't a high school course. It's a college course. So, you know, as I said, people did great in classes last time. Now, there's several people who aren't here today, which is at least one of them is sick and coughing and stuff and didn't want to infect everybody. So, and again, somebody who's doing quite well. Several people who aren't here today who were doing very well in class. You have to follow up. You have to do the assignment. And the assignment was prepare for this quiz. Okay. I also noticed some people haven't done the assignment, the exponential. Actually, I think maybe the first one that was going to do tonight. Okay, make sure you do those assignments on my open math. If you don't know where to find them, go back and review it. Or email me, but first read everything it says on the open math page because it tells you where to find the assignments. Okay. And I think most people did the introduction by open math, so I assume you know how to find these things. Okay. And I'm sure almost everybody does, but if you miss something, go back and read it again. If you still can't find it, email me, I'll tell you where to look, but find it yourself because you're going to remember that. I don't mind taking a minute. Okay, there aren't that many of them. Everybody asked me for that instruction, I'd be able to do it. But I want you to do it yourself, okay? So make sure you do that. Because I predict this class is going to do quite well if you do everything you need to do, okay? And again, just to repeat, you need to be able to make these graphs perfectly, no mistakes, okay? No misplaced points. Everything divided up the way it's supposed to be divided up. If you go twice as close, you go twice as close. And then if you go twice as close again, you don't have three equally spaced lines. You have a line here and then a line in a much smaller and half the interval. Okay. We don't want to see that stuff because it distorts your graphs. And then when you try to make estimates from your graphs, so it's a very straightforward algorithm. Everybody did it well last time. And a lot of you are doing it pretty well this time. And I'll give you full credit on this quiz, but that's not going to excuse you from having to do the quiz where you got to do all three. To give you full credit for the quiz, you got to do one of them right. Okay. But you're still going to have to pass the quiz and do all three. Okay? And I'll give that one more time. Next class, but I'm only going to give you 5 minutes. Then you're going to have to go to the testing center. And very likely, the quiz you have in the testing center will ask you to do all 5. Try to do the other 2. They're very simple. Okay, they're not difficult, but you have to follow up and make sure you know how to do these things. This is essential. It's all we've done pretty much in class so far. We're finished a week of classes. Okay. This is essentially a one-day assignment that I usually allow 2 for. All right. Again, y'all have demonstrated you can do it. Okay. Follow up, make sure you can do it when you need to. All right. Okay, we just did a little assessment of algebra skills. And I haven't been over them, but just looking over your shoulders, obviously, uh, most of you kind of rusty. That's okay if it comes back to you. I'll go over them a little more and see what you say. But okay, now why am I starting out this course by drawing these pictures? First place, because it's something you can learn. Okay, if I start out with the heavy algebra, most of you are not in a position, or at least many of you aren't in a position to be able to do it right. I'd be talking in a foreign language. The algebra you need to talk to an inverse function, or the algebra you need for quadratic equations or exponential equations and stuff. Okay, so we start with these pictures, and then we look at the algebra that's involved with the pictures, and we learn to do that algebra. Okay. So, to the extent that you're rusty, it should come back to you easily. If it's that you never really learned it, then you should consider at least enrolling in the support course or the intermediate algebra course along with this. Okay. There are distant sections of those courses. You don't have time to attend the class. The classes are well worthwhile. Now, that said, I post the videos for those classes. You can also look at those videos. So if we're doing something you don't understand, you're going to get a pretty detailed explanation. Okay. Even if you're not enrolled, you're welcome to use the videos. But I'm not going to work with you on those courses unless you're in them. Okay. Work with you on this course, but I won't work with you on those courses. And that's just because college forbids me. Okay. There aren't that many of you. I would be willing, but the college doesn't allow it. Okay. If I'm going to work with you in a course, you've got to be enrolled in the course. Okay. That said, now let's look at these expressions. Just take a look at them and see if there's anything in any pattern you see to these expressions. Anything that they all have in common, things that they don't have in common, and just write down a couple of notes. What do you see in these expressions? They all have a couple of things in common, but there's something that's different. Can you phrase what they have in common in words? And can you phrase what's different in words? That's a tough thing to do because you're not used to putting words on mathematics. Do your best with it. Okay. What I see looks pretty good. Now, some of you are still copying these things down rather than looking at them. Okay. But sometimes that's what you need to do in order to see. It goes with research that appears to show that doing things on paper is more beneficial than just about any other way to do it. Okay. But I see people forming good sentences, making good statements. Okay. Which again shows me, not to keep harping on the idea, but it shows me y'all are extremely capable. Okay. But you gotta know what it means to learn the thing so that you come in knowing how to do stuff. Okay. Just being able to do it in class when I'm showing you step by step. That's the start. Then you gotta finish it. Okay. Gotta take that idea and run with it. See what you can do, because again, I think y'all can do extremely well. Okay. So let's see what else. Okay, well, let's see the everyone has X, A, Y, and K, right? In whatever order you want to leave. Okay. X and H always appear as X minus H. So everyone has an x minus h. Okay, a lot of us saw that. If you didn't, well, you saw other things. Everybody saw some good things. That's kind of a big deal. And then K. Always tacked on to a lot of other stuff. At the end, and I'll say a plus K, it's always a plus K, just like it's always, H only appears as part of an X minus H, right? Okay, good, good. Now. You have. Which appears to be related to the squaring curve, exponential curve, reciprocal curve. Okay, so, I just looked at about half the class. Half of you seem to be right on track with that. The squaring curve is this one, right? Why? Because the X minus H is squared. Okay? Makes sense? So that's number 4. Okay. What about the reciprocal curve? Everybody think about it for a minute, see which one of these you might say would be the reciprocal curve. Then we're going to ask everybody to suddenly hold up the right number of fingers. If you think it's number 7, you're just going to go. Okay. I mean, not as fast as I did. Nobody can move that fast. But pop it right up. Pop the number right up there. Okay. Give you a few seconds to think, to look. Okay, I want everybody's, we'll leave one hand. Okay, everybody's hand to go up. And if you don't know, just give me a fist. Don't swing it at me, it's frightened me to death, but hold up a fist, okay? Ready? 1, 2, 3. Okay. Okay, what do I mean by reciprocal? That's you got it. But what do you mean by reciprocal? Well, that's a term that's common in your prerequisite courses. Okay. I'm not shaming you because you don't know. Maybe I'm shaming those prerequisite courses because I didn't use common mathematical terminology. And maybe it's because you didn't work as hard as you could have, nobody ever does. Okay. Yeah, so some people do. But one way or another, reciprocal means like 1 over. Like the reciprocal of 2 is 1 divided by 2. Reciprocal of 5/8 is 8/5. Okay, you turn it upside down. So now, which one do you think is the reciprocal? A couple of you held up the right number of fingers. If you got fingers to hold them up. Not sure. Just throw a fist at me. Okay. Yeah, that's reciprocal of X minus H. It squares X minus H. Here, X minus H is squared. Here, X minus H is in the reciprocal. Okay. What about exponential? What would you think? what word does exponential come from? Comes from the word exponent, right? You know what an exponent is? Okay, one thing I didn't tell you, not only don't walk in front of the camera, don't talk when the camera's on. Privacy laws. We can't really have a class and record it because of privacy laws, but we're doing it anyway. But if you got an answer, just, yeah, let me know you have an answer, pause the video. Okay, so let me let you answer now. Oh, come on now, the thing was on the pause button again. We got a very good answer. Exponents like number that's up here, like x squared, choose the exponent. Got exponents here, there's an exponent, there's an exponent there, and there's one, right? Which one would you say is the exponential function? Which one of these things, which one of these exponents is different from the others? It's this one because the others have twos or threes, they're numbers. This one has a symbol, x minus h. Okay, that's an exponential function. And showed you last time. I'm going to show you again. I showed you last time how to graph it. Okay, you go back to the video and look at it. Videos at the assignments page, find the assignments page from the welcome announcement in Canvas, right? So if you don't know what the videos are by now, well, now, hopefully you do. In other words, just do what you were instructed to do. And most of you have. I mean, you know, most of you got yourselves registered in WebAssign. Okay. So it means you were reading the directions. Read them all at the assignments page. Most of you didn't email me when you got the assignments page, so we'll do. You're supposed to do right now. Okay, so anyhow, that's your exponential function, okay? Well, there are two others. I'm going to show you how to graph them. Okay. There's the cubic function. All right. Okay, this is number. This is number. Cubic function, reciprocal square function, right? I bet everybody can identify the cubic function. Well, I hope so. Can everybody identify the cubic function? Can you hold up? And just be careful which finger you hold up. Yep. Okay. Very good. Okay. So yeah, that's cubing. That's cube. And we know that terminology. Okay. Now, by the process of elimination, this is a reciprocal square. But is it obvious why that's a reciprocal square? It's a reciprocal because x minus h is in the denominator. Okay. And it's squared. That's the reciprocal square function. So let's quickly learn how to graph those functions. Really, kind of the first thing we want to do is we've got to know where the red dot is. And it's one of two places. It's either at the midpoint of the lower edge of your rectangle, or it's in the middle of your rectangle. Okay. For the reciprocal function, it would be in the middle of the rectangle, but for the reciprocal square, it's down here. Okay. Now we subdivide this thing, divide it in half, divide it in half, then divide the right half in half, then divide the remaining half toward the middle in half, and we have this. Okay, then we do the same thing from the left, and I'm not going to. Yeah, we'll say it. You know, we go from the right edge toward the center, we go halfway, and then we go halfway from there to the center. Then from the left edge, we go halfway to the center, and from there we go halfway to the center. And that's the way we divide it up for most of these functions. For the exponential function, we only divide it once because we don't need this second line toward the center. Okay. Now you understand that. You probably don't need to review the long explanation we had a week ago today. Okay, but if you need it, Go back to the video and do it. Okay, and then we divide it up just the way we did the squaring function, or first function, with horizontal lines. We go start at the top, go halfway, which puts us on the line we already drew, right? Then we go halfway, we're going from the upper edge to the lower edge, halfway each time. So we get here. And then here. And then here. And then here. There are 1, 2, 3, 4, 5 lines inside the rectangle. And there are 5 lines here inside the rectangle. Right? Then we start at the line to the left of the center line at the upper edge. Then we go down to and over 1. Down to over 1. Turns out we don't need this last line. So really, we only need 4 horizontal lines for this one. But I'm saying just do it the way you did the squaring graph. It turns out you won't need that last line. Okay. So if you understand that, you can leave it on. On the right, we do exactly the same thing. Notice it's going to be symmetric. We start on the line to the right of the upper edge, and then we go over 1, down 2, over 1, down 2. And as with the reciprocal function, we don't connect the left to the right. Everything to the left of the center line has its own curve, and everything to the right of the center line has its own curve. And there's your reciprocal square graph. Now I'm going to tell you a little more. If this point is HK, equation is y equals x minus h squared plus k. Assuming that this is a 4x4 rectangle. Okay. Now that's something you need to remember, because that relates to pictures of these things. Now there's even a neater way to do that, but right now, there's your rule. Okay, make sense? Is that easy to understand? If you're going to remember it now for the rest of the course, say yes, and then do it. Okay? That's really, really important. Very, very soon. Okay? Like your assignment this weekend. Okay? Okay, well. Oh yeah, there's one other thing I want to ask you. There was an assignment. We were supposed to do graph, mix estimates or something like that. It was right there on the assignments page. Did you see it? Did you do it? Anybody do it? Okay, well, I'm gonna stop for a second, just make sure I'm not lying to you. Look, I just checked. I went to the assignments page and there it was. Okay. So again, and I'm saying this, I just said it to everybody, people who maybe are here, really got to read the assignments page and do what it says. We're laying the foundation for the whole course. And we're going to start hanging algebra on it. First thing you got to do is be able to draw these graphs. Nothing complicated about this. Understand the rule? If you don't, it's there in print. Read the assignments page. Okay. got a whole explanation, which you should read and understand after you've done some of this. But it's not new. Okay. Start the upper edge to the left, start the upper edge to the right of the center, over one, down two, over one, down two, over one, down two, over one, down two. Okay? And there's only one way to go over one if you start here and stay on the same side. Anyhow, okay, there it is. Okay, that's a reciprocal square graph. The cubic graph is a little weirder. I'm going to make kind of a tall rectangle. Got to be tall because of what you're going to do with this. For the cubing function, red dots in the center. We'll always do lines through the red dot, always lines through the center of the rectangle. Okay, and we divide it vertically, using vertical lines, same way we do on most of the graphs. And then with horizontal lines, we go there, we go twice as close to the middle for the lower edge, then we go twice as close. 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 Maybe we go one more. I don't want just kind of see how many go. 1, 2, 3, 4, 5, 6. Yeah, there's another one in there. That's really, really, really close. So that's why I make a big tall rectangle to do the cubing function. Because even at that, with the chalk, which has kind of a light line, I can't really even draw with that. Okay. And then there are many ways to see this. And I give me a D minus for the day. Okay. Start over. Kind of went autopilot. I was thinking first quadrant. Okay, that's my excuse. And make it even taller. Okay, same thing. What I'm going to subdivide all those times is just toward the center. Well, I'm getting further than that. Okay, now I'm dividing from the edge toward the center, not from the top edge toward the bottom edge. I did that without thinking. I should. So top edge toward the center, then halfway to the center, then halfway to the center, and halfway to the center, and halfway to the center, and once more. Okay, I think I've got enough. Not really, but okay. We start here. Then we go left 1, down 3, all the way down to here. Then we go left 1, down 3. That's going to put us really, really close to that center line. Okay. And it's not really practical to draw all the lines, although maybe the instruction that I printed says to do that. The next thing you go through is the red dot. So that's to the right. Over 1, down 3, over 1, down 3. On the left, you divide it from the lower edge toward the center a bunch of times. you're gonna need at least 6 lines. Six lines really close. Okay, and then we go here, over 1 and up 3. Over 1 and up 3. So it's much like the other graphs, except that we really can't draw all the lines we need to continue the over 1 down through over 1 down. Okay. If we could draw all the lines, we could use that. And now the graph looks like this. It's very flat toward the middle. And when people draw this graph, they usually don't make it flat enough toward the middle. That's the reason I use these subdivisions to emphasize just how flat it's got to end up. Doesn't have any corners, it doesn't have any sudden changes in direction, but it changes very quickly and smoothly. Here, here. Okay. Now, you can buy video or by reading the instructions, a combination thereof, pushing how to do it. Okay. So I'll probably put these two on the quiz Tuesday. Probably not going to give you enough time to draw them all. Okay. So the ones I'll just really hold you responsible are of these 3. But be prepared to be able to do these 2 as well. All right. Because if you don't pass the quiz Tuesday by getting 3 of them completely right in 5 minutes, then go to Learning Lab and do all 5. That's insane. Okay. They're going to have to keep going back until you get them all completely right. All right. If you do that much, you have a really good foundation whether we know it or not. Now, what do you think the equation is for this one? If the coordinates of this red dot are HK, the y equals what? Okay, so we got a straightforward equation. You got to read it off the list over there. Not sure that's visible on the screen right now. As you can see, but there it is. Okay. And similar for all the other graphs. Now, last time I gave you the equation of a squaring graph. Okay. And we verified that the points in the graph match square graph. Okay. And this, okay, this is also a 16/4 rectangle. You got to know that. Now, if we look at these expressions, they all have a certain form. They all have the form y equals f of x minus h plus k. Now, this is function notation. Something you're supposed to know when you come in here, but people are usually not very good at it. I went off to one of the top technological universities in the country. They didn't offer any courses below big, tough calculus. Okay, if you weren't ready for that, they didn't let you in. I had good SAT scores. The only thing I missed on the SAT, I think, my algebra was really good. So, well, I didn't understand function notation because nobody had ever showed it to me. I'd seen it, and it just had no mystery. I know that function notation can be a stretch. Not figured out pretty quickly, but you know. It did impede my learning of calculus for a few days. That kind of got in my way. Don't want it to get in your way. Okay, so what do I mean by this? F of x minus h. Well, if f of x equals x squared, then f of x minus h is x minus h squared. Whatever f does to x, it's going to do that to x minus h. And realize that the camera's not quite. That's not the notes not quite in the right place for the camera. Okay, there we go. Now, if you don't understand function notation, I really urge you to look at the MD 61 videos from this. Okay. We could explain function notations a lot of time on it. But that's the pattern. So I'm using this pattern to refresh you on function notation or to introduce you to it. Now, if f of x minus h equals s minus h squared, then y equals f of x minus h plus k can be written how? Write it out in your paper. Using the fact that f of x minus h is x minus h squared. Okay. How do you write this? Well, look, f of x minus h equals x minus h squared. So we just write this, but we're replacing f of x minus h with what it's equal to, right? You're replacing equals with equals. It's a fundamental thing that you do in algebra, okay? So x minus h squared is the same thing as f of x minus h, so we get y equals x minus h squared plus k. Okay. Now, if f of x equals 1 over x, then if instead of x, you've got x minus h, then this x has to be x minus h. Well, we just do the same thing. Once you know that f of x minus h is 1 over x minus h, this expression here that we keep repeating gives you this, which is, of course, this. Okay. if f of x is x squared, then that'd be this, right? Now, let me turn the question around. If we want to get number 3 here. Okay. Blackboard back there. Okay. If y equals f of x minus h plus k is y equals 2 to the x minus h plus k, and what's f of x? Write it down if you know. And write it down quickly because I only got about 3 minutes. Okay, somebody got this because it's a tricky question. Let's. Okay. What's f of x got to equal? Well, your f of x minus h better be 2 to the x minus h, because we got x minus f of x minus h here. We got 2 to x minus h here. Everything else is the same here as it is here. So f of x minus h must be 2 to the x minus h. Well, what's this saying? It says whatever's in parentheses, that becomes the exponent, right? That's what this will tell you. Whatever's in parentheses becomes the exponent. So if we write f of x, thing in parentheses, which is x, becomes the exponent. Okay, just like over here, if f of x equals x squared, then whatever's in parentheses gets squared. And that's what happened. You put x minus h in here, it got squared. This is a squaring function. This is the reciprocal function. Whatever's in parentheses goes underneath 1. You got x minus h, you get 1 over x minus h. Okay. So your f of x to this function, well, x minus h is getting cubed. So it must be the cubing function, f of x equals x cubed. In this case, you're taking x minus h, you're taking its reciprocal, and you're squaring it. So f of x must be 1 over x squared. Okay. So pick up on this next time. I'm just going to finish making this list. Another class to go to, you can go, just don't talk. You go out, I'll turn on the camera. It's just going to take a minute to do this. Got a question? You can do it. Okay, so I want there the f of x. And notice it's always the same expression here. Every one of these follows this pattern. Hopefully that's good motivation for learning function notation.